Assalamualaikum guys. Welcome to Civil Engineering 24/7 YouTube channel. This is Adnan Ahmed and you are watching Civil Engineering 24/7. Hope everyone is fine. So in today's lecture, we will move towards structural analysis. Simple overview, small overview with some detailed points. Okay. So what is structural analysis? So for your kind information who are new to civil engineering, they can just get into their mind what is structural analysis. Okay. Structural analysis is a very important subject in civil engineering. So let me tell what it shows. How much stress is induced in beams, columns and truss. So in these three structures we find also frames. We find the load conditions, how much it is induced. Suppose this is a beam, okay, then there is a load. What is the deflection? How can I overcome the deflection? How can I reduce or make the point at zero kilonewtons maximum intensity at level point? I mean to say, if there is the load application, so there should be 0 kilonewtons. That is the principle of structural analysis. That to bring, there should be minimum or maximum intensity of 0 kilonewtons at a point. Okay. So I have some structures, means I have some thread of flow chart like see. Thread is nothing but when you get a structure, this is a structure, right? When you get some loading, that is a thread. Loading is a thread. Input, that is input. You find input and you do some analysis. Then suddenly what happens? You move towards structure analysis. You do analysis. X-ray. Here X-ray is performed. Okay. X-ray of structure is performed. The structure gets fever. After the fever, it gets some X-ray. We do some X-ray and we get some response sheet. Response sheet in the sense you go for a blood test and you check what happens, whether the people is suffering from fever, dengue, malaria, like that, you get a response output, right? Yeah, after that, you make the structure again at this point. This is the final point where you get response output of structure. So, input, analysis, output. Create structure response, okay? Next, some formulas you need to know in structural analysis. That is for strain energy. What is strain energy? Load stored in the body is called strain energy. Energy stored per unit volume is known as strain energy. I have also seen some researches on strain energy in physics. You know physics? In physics we use strain energy, but it is somewhat different here. Strain energy means energy stored per unit volume, oral definition, okay? So next we see some formulas. This is U, that is strain energy. U is indicated with strain energy, okay? The U is indicated with strain energy. U is equal to half into P into delta L. What is P here? P is load, okay? And delta L is change in length. What is change in length? Suppose this is a beam. Some tension is there, then what happens? Some extension, elongation. The elongation is known as delta L. Okay, the elongation in your SOM, strength of materials, it will be. This concept is in your strength of materials also same. But before the strength of materials, everything structural analysis, theory of structures is very different in this aspect. Let's move towards another formula. That is your U1, strain energy 1. That is for different load conditions we have different formulas. So for different structures. So U1 is 0 to L integration P square to AE dx is your axial load for truss. Note it down guys. Please maintain notes. For truss we use this formula. Then U2 for 0 to L integration M square to EI. What is M square here? Moment. They will mention moment in beam. Suppose it is a beam here. Okay, they will mention some moment of 20 kilonewtons. That we need to mention here. I need to follow the procedure of integration in mathematical order. Okay. What is that bending moment? It will be somewhat tough, but if you do, it is very easy if you understand the concept behind it. Some struggles will be, but you can understand. Okay, this is the formula we use for strain energy to M square divided by 2 EI. Directly keep in calculator M square value and divide. You get answer for this question. For bending moment, the condition for this is axial load for truss, and this 0 to L M square by 2 EI dx is for bending moment for beams. Okay, for beams. Then next. See here guys, U3, that is T square by 2 Gj. What is T square? Your torsional. What is torsion? Some rigidity. If you twisting, like this twisting is known as torsion, okay, 2 Gj. You keep torsion value for bending moment for beams, trusses, frames, we use these conditions. So these three conditions, these three formulas are applied, okay. These are very important guys. Next we go for Castigliane's theorems and Castigliane's theorems, first theorems is there and energy theorems is there, but that much is no needed. For heading back to the subject, I have just explained this, some few points of structural analysis. Okay, structural analysis is used in StatPro guys. It is very important. StatPro, structural analysis and design, where you design some columns, beams, slabs, you apply some different kinds of wind loads, dead loads, and you check. Okay, you have to gain the knowledge of the RCS design of reinforcement concrete structures also for getting this subject. Okay, I guess everyone is getting this subject, some formulas and what was the reason behind this subject and everything, right? So thank you guys. Meet you next session. Until then, please subscribe the channel, share the channel, like the channel, and please maintain the notes while lighting. Meet you next session, guys.